A lot of this lesson is a quick review of what you know about angles, and then we can go ahead and use that with some algebraic problems that comes in at the end of the lesson. But let's make sure that we are all on the same page, because if you don't know the basics, you can't do the algebra. So, first of all, I've drawn an angle. I'd like you to kind of replicate this angle in your notebook quickly, make it look approximately the same, and put the letters in the same positions on it. And we're going to decide the different ways we could name this angle. If you want me to look at this angle in particular, you can say, this is Doble. Refer to angle what? What's one way you could name this? One way. Ellie? Angle A, C, B. So true. What's another way you could call this angle? What's another name for it? Katie? BCA. Good. Angle BCA. Now, since it's the only named angle on this page, and there's only one main angle here, you could get away with calling it angle C. But if you did this, and there was more than one angle there, then you wouldn't do that. Okay? So, be careful of that. What can we not call it? What is a bad name for this angle? Nathan? ABC. What else is a bad name? Costa?
BAC.
BAC. Because anytime you name an angle, the vertex point has to be in the middle. So just so you remember, this point where the two rays come together is called the vertex of the angle. And when you name it, the vertex always has to be in the middle. Okay? So I got 4 angles down here. 3 of them are review. The 4th might be new for you. How do we classify these according to their size? What's the first one called? What kind of angle, right? It's an acute angle. Its degree measured is less than 90 degrees. Less than 90 degrees. What can we call this angle right here? Peyton?
Right angle.
The right angle. What do we know about its degree measure, Peyton? It equals 90 degrees. Good. And this angle, what about that one, Jack? Obtuse. And what do we know about its measure, Jack?
It's greater than 90 degrees.
Greater than 90 degrees, but less than
360.
180,
Oh.
less than 180. So it's between, good guess, between 90 and 180 degrees. This is the angle. If I look at this angle and I'm talking about the part outside of it here, where the circular angle thing is called, has a special name, and many of you might not know it. Katie?
Wait, is that angle more than 180 degrees?
Yep, this angle up here is more than 180, so we don't call it an obtuse angle. It has a different name. Do you think you know, Katie?
Isn't it adjacent angle?
No, that's going to come in on something else. This is called a reflex angle. Reflex angle. So that one's new to most of you. Make sure you put an asterisk by it or highlight it. You need to make sure you know that that out there is called a reflex angle, and it is between 180 and 360 degrees. So that's a little new tidbit for you. Any questions on any of that? Going too fast through this review stuff?
Not really.
Okay, moving on. Okay, I want to make sure that you remember how to measure angles. This is review also. The plastic sheets on your desk and protractors are there for measuring. You have the same picture that I have. Please do not write on. There's been some writing going on my rulers, which is bad. You're not supposed to write on anything that's not yours. Don't write on the protractors. Okay, so first of all, just to refresh anybody's memory who's going, oh, I don't remember how to do this. The first angle we're going to measure is angle A. And the way to do it is to bring your protractor near angle A. Always ask yourself first, what kind of angle is it? Angle A, what kind of angle is angle A, right? It's an acute angle, so what would I expect of its measurements? Less than 90. Okay. So when I use my protractor, I should keep in mind that I'm expecting an angle less than 90 degrees. I take my protractor, I put the center point of the protractor on the vertex of the angle, and then I rotate down so that the 0 line is on one side of my angle. And then I got to choose which scale I use. Which scale should I be reading in this instance, the outside one or the inside one? On mine up here. Which one should I be reading? What do you think, Erin? The outside. I want to measure from 0 up. And so I go up and I get 76 degrees. Do you see 76 degrees plus or minus a degree?
Yep.
Yeah, everybody good with that? Anyone confused? All right, let's find out by having you measure angle B and checking with your partner. Let's go ahead and measure B and check with your partner.
Right over there.
Got it? Okay. What did you guys say? Degree? You gotta put the dashed 0 line on one side of the angle. Yep. And now you read up. Yep. You must be reading something a little bit wrong, so let's see how you're reading it.
Oh, it's just kind of
Yep. Okay. What did you guys decide? Did you guys decide?
Yes.
22. This is all. This protractor's
Don't play with it.
So that's what happens when kids play with them, fling them, spin them. Don't do that. Okay. 25 to 27 degrees. You guys all seem pretty good on that. Now, here's the next thing. This angle C, what kind of angle is angle C? Kind of angle, Peyton? Reflex. A reflex angle. Our protractor doesn't allow us to measure this angle. So we need another strategy. What is a strategy you propose we could do to come up with the measure of angle C? Trikaska?
You could measure the two angles and add it.
You could measure the two parts and add them together, yes. What if this line wasn't here and you couldn't do that? Then what? Then what? Carolyn?
You could measure the acute side of it and then subtract it from 360.
Yes. You could measure the acute side, which is this piece over here, and subtract from 360. Go ahead and choose one of those strategies and check with your partners. What are you measuring first? Oh, so what part of it? You can't. 12 of 60. And we'll have probably another quiz or two. All right. So my preference actually is to measure AB all at once and subtract from 360 because I find that there's the least amount of room for error on my part. Because couldn't make an addition error, or I might not be off measuring both of these parts. That's just my personal preference. So when I measure my angle AB, I get that it comes out to 100 degrees. So I take my total of the degrees around a point 360 and I subtract my angle A plus angle B measured and I get 260 degrees. So was your answer in that range?
Right on this.
Okay.
Is 258 in that range?
258 is pretty close.
256.
That's getting a little out. That's getting a little wider than I'd like you to be. How did you get it?
I added 2 angles.
You added the 2 angles. See, there is more room for error when you add those 2 pieces together, so you might want to go back and check that out. All right, any other questions? All right, let's move on then. We have to review some special kinds of angle pairs that will help us to solve problems. First kind are complementary angles. Complementary angles are 2 angles that have a special sum. Complementary angles always total, right? Yes.
90.
90. Complementary angles total 90 degrees. Okay, so now listen to this question orally. And you have homework problem to warm up or two like this. So angle A and angle B are complementary angles, and angle A is 20 degrees. What is angle B? Sophia? 70 degrees. 2 angles that are complementary, they total 90. Supplementary angles also have a special sum. So what you guess for the street?
180.
Very good. Supplementary angles total 180. Same idea. How do you remember which is which, Mrs. Doble? Well, C comes before S and 90 comes before 180. So when I had to remember it the first time, that's kind of how I remembered it. All right. Adjacent angles on a line. Draw this picture with me. A freehand line. And off of it, draw a ray.
Oh,
I thought Ray was going to like that.
alright.
And that creates 2 adjacent angles on a line, angle X and angle Y. They're called adjacent because they're touching. They share this ray, and they're on a line. This shows up a lot. A lot of times when you're looking at one of these diagrams, this will help you unlock the problem. What do we know about angle X and angle Y? What special relationship do they have? Angela? Yeah, they total 180. So adjacent angles on a line total 180 degrees. It's often helpful for helping you figure out a problem. Well, Mrs. Doble, isn't that like the same as supplementary? Well, they're just kind of used in different situations. This, you often won't see these words at all, but you're just figuring it out from looking at the picture. In textbook writing, you'll often see supplementary angles written. These angles are supplementary. So yes, both instances they total 180. It's just you got to interpret them in the right situations. Finally, the picture for vertical angles. See if you guys remember this. Vertical angle picture looking like this. And let's talk about angle A and angle B. What do we know about angle A and angle B? Jillian? They're the same. Angle A equals angle B. Vertical angles always equal each other. They're like those 2 V's pointing in at each other. They're always congruent. In this picture, there's also another set of vertical angles. Don't miss out on the fact that these obtuse angles are also vertical and will be equal to each other. Any questions about that? Those are factoids you just need to have in order to be successful. All right, so let's tie it all together with some algebra. This is where it becomes fun. Yeah, I'm going to have you draw this first picture. Take a second to sketch it. looking at this, the directions might say something like calculate the unknowns or find the unknowns. What are the unknowns in my first sketch I just had you copy down? What unknowns are we looking for here? Ben?
P and X.
Yeah, we have to find P and X, all right? Let's just start with finding P. Get that over with. Any ideas what we could use to help us figure out what it is, Peyton?
Oh, like that first one is what we agree with threes, and half of it is a three, and the other one has 3 p's, so you could just divide it by 3.
Okay, so let me slow down what Peyton said. Peyton said he sees this vertical line right here, and half of it over here is 90 because of this right angle. So that means the other half has to be 90. And you said 3p,
Yeah.
which you're getting from your 2p plus p equals 90. You did all that kind of fast because I am confused about that. So what does p have to be, Peyton? 30. We found the first unknown. Questions? All right. Let's talk about finding x then, because that's the other unknown that Ben mentioned. What can we do to find x? Oh, come on. Talk to your partner quick. Ray's the only one who's got an idea? Come on, guys.
You could have X's, like, get rid of the conscious.
Oh, yeah.
Detailed explanation.
And that's how.
All right. Okay. So there wasn't silence there, so you guys did have some ideas. What's your idea? What concept could you use, or what relationship can you use to come up with this? Sophia?
Making an equation.
Okay, how so?
You could simplify it to square x,
Before you simplify, just tell me what you're thinking.
like, to find x, make an equation.
Okay, tell me what equation. What are you putting equal to what?
Well, we're not equal, so,
Okay, are you looking down here? And what are you thinking about this down here? Okay, well, you started to say 4x, right? What are you doing, Sophia?
say x plus x, and then we could do
So you're adding these two expressions. Okay, so what do we know about those two expressions when we add them together? What do we know about them? Jillian?
equal 180.
They equal 180, very good, because they're adjacent angles on a line. Now you have an equation. Go ahead and solve it and check with your neighbor as to what the answer is. Something really important in algebra that I see some of you forgetting to do is when you have a whole bunch of stuff on one side of the equation, simplify it before you start to solve. If you need to rewrite subtraction is adding the opposite, that's fine. Combine your like terms over here, and what does this left side of the equation simplify to? Nathan? 4x minus 6, or some of you would say 4x plus negative 6 equals 180. Now that it's simplified, solve it. What's the first step in solving here? Ellie?
You have to add 6 to both sides.
Add 6 to both sides. So you get 4x equals 186. And then you divide, and you get x equals 46.5 degrees. It's all right to not have a whole number, okay? Those of you who got stuck with your algebra, did you get it straight?
Yep.
All right. Let's look at this example. You don't have to copy this one down unless you want to. But this is like a more complicated version of what you'll see on your homework tonight. There's 3 unknowns in here, and we can find all of them. All right? So, who wants to give a suggestion as to where we can start? What would you do first? You first, Katie.
Well, 2y and x, the same as across, they're the same,
Yep.
so,
They're equal to each other, yeah.
um,
But we still got to find out one of them. Okay, so is there one of those letters you can figure out for sure? Jack?
Well, z would be equal to 48 and
55. So if
Why?
Because they're vertical angles.
Yeah, this angle right here,
And then the other ones would be equal if you multiply.
this one and this one are equal, they're vertical angles. So Jack says find Z. And Z will equal 48 plus 55. What is 48 plus 55? Ray?
Adam Abuajir,
103
Asir
degrees.
Ali, Layla Madati,
Yes, Ray.
Kelly Torrance, Zoa Hamas, and Mills Coloffice, please.
Go ahead.
And subtract that from 180 to get X.
Okay, so Ray says these three angles are on a line, so he can get angle X by doing 180 minus 48 plus 55. And we knew that that's 103.
Shura Hamas,
Oh,
Sadia, and Mills Coloffice.
It's 180 minus 103. Hold on, you still with me?
Yes,
Good, tell me what 180 minus 103 is then.
that would be, well, 70, wait, yeah, 73,
Nope,
70, not, 7.
77 degrees. I've got X and Z, I still need Y. Still need Y. Ellie?
Well, is this y?
Y is half of X because 2Y equals X. So 2Y equals 77, Y equals 38.5. All right, did you write down all the problems you have to do?